Here we have a cube reservoir of side A, as you see, is open and connected to the cylindrical tube of section S. And we put water in the system to fill all the cube and the cylinder tube to a height h. Okay, so we have a water to the point, this point, okay, at the height h, at a height a plus h. Okay, we have a total height of water equals to a plus h, the total one. Anyway, I want to find the total force applied on the bottom, on the top, and on the lateral side of the cube. Okay, so we have to find the total force applied on this side, on the top, and on the lateral side. Let me start by the bottom. Okay, here you know we have this surface. As we have a horizontal plane, in this case we have a constant pressure at any point on the plane. So we can apply P. If I take, for example, the surface like this, we have P bottom, PB. Okay, PB is the force, is the pressure applied on the, we can say on the internal side of the bottom, because we have here the bottom here. From the internal side we have PB. Let me put it in red. Here we have PB. You know PB is the pressure applied by the quantity of water here plus P0. Okay, we can calculate later. Okay, now here we have PB applied from the internal side, and here you know we have the atmospheric pressure applied from the external side. We have P0. I want to calculate the total force applied on the bottom of the cube. So we have the force applied from the internal side and the force applied from the external side. So here we have P0. For PB, we have FB, and for P0, we have F0. Okay, you know it's down and up, so the total F, we can F total at the bottom equals to FB minus FO. If I take the positive direction is downwards. Okay, so F total equals to FB minus FO. We can have the total F applied on this wall, on this side. Okay, you know we have, as we have a constant P, we can say F equals to P times A. You know A is the area of this side. Okay, we have A, which is equal to A square, A small square. So F at the bottom, first of all, let me calculate each one. This one equals to P bottom times A, and this one equals to P O times A. Okay, let me calculate FB first of all. You know, okay, we have FP equals to PB. We can calculate PB. To calculate PB, as you know, in the hydrostatic case, when we have a static fluid, we have to take a point M at the bottom where I want to calculate P, and we can take a point N at the top where we have P 0 at this point. So in this case, we can find PB, you know, between M and N, we have the principle of hydrostatic equation where P below equals to P above plus rho G times the distance and of the height between the point M and the point N, which is equal to small a plus h. We have a plus h. Okay, this is PM. You know, PM, I mean PB. PM at the bottom, we have PB. And PN equals to PO plus rho G A plus H. This is the value of PB. So we can write F total at the bottom. F total at the bottom equals to PB P0 plus rho G A plus H times A square plus or minus P0A square. So we have P0A square minus P0A square. We can get finally F total at the bottom. We have rho G A plus H A square. Okay, this is a value of the total force applied on the wall. You can say this value is equal to the total force applied by the water, okay? Because here PB inside equals to the force applied or the pressure applied by the water plus P0, okay? If we eliminate P0, we get only the force applied or the pressure applied by the water inside the cube and the tube. Okay, this is the first or part one, P at the bottom. We can follow the same calculation to find P at the top of the cube. At the top of the cube, if you look well, we have a side like this. Okay, this one is this one, this side. And we have a hole here because we have a tube at this point. Here we have a tube. So if I take only the top of the cube, we have this shape. We have the total area minus the small one. You know, the small one, the small hole has a surface equals to small s, this one, and the total one has area equals to a square, and I need to calculate the force applied by the water, or the total one applied on this plane. Here, the contact of the applied force will be only on this area, this one. Okay, we can say the blue area equals to a total minus small area. Okay, the total one minus the small one. This is the area where we have the applied force on the top of the cube. Okay, now let me start the calculation. First of all, on this wall, you know, as we have a horizontal plane, P at any point is constant. If I take the top like this, okay, the top like this, we have here, okay, we can say like like this. Okay, I take the lateral view. Here, we as the P at any point is constant, so we have a total P applied on the total surface. We can say P top, P at the top. We can say P at this point equals to P at this point, at this point, at this point. At any point, we have the same pressure. As you know, same level, same liquid. So here, if you look well, P here is equal to P here, P here, P at any point here. Okay, P applied is constant at any point on the top of the cube, as we have a horizontal plane. So we have the same P. P at the top, we can say we have F at the top is the force, total force applied from the internal side, and also we have from the external side, we have F0. Okay, F0. We can say F total, F total at the top equals to F applied from inside, it's called F top, minus F applied from outside, F0. Okay, we can follow the same calculation as before. You know, F top equals to P at the top times the area. You know, the area here equals to A minus S, because we have a contact only here. We don't have any applied F at this region, so we have here. So we have A minus S, the total area minus this one. Okay, this is P at the top times A minus S minus P0 A minus S. Okay, we have to calculate P top. To calculate, we can take 1 point here and 1 point here. We can say here a point B and B prime. Okay, you know at B prime we have P0. So we can say here P as a point B minus P or equal to P B prime plus rho G. H between B and B prime will be small h. Okay, you know PB is equal to P top equals to PB prime equals to P0 plus rho G H. Okay, we substitute the value of P top here to get we can say F total at the top side equals to P top equals to PO plus rho G H. Okay, times A minus S minus PO A minus S, because here, as you see, we have P0 only here at any point here. We don't have here. So we can eliminate P0 A minus S and P0 A minus S to get finally P top equals to rho G H A minus S. This is the total F applied on the top of the cube. Okay, the total one. Now let's go to the lateral side of the cube. In the case of lateral side, you know, we can take this one. This one. This one has area equals to A square, as we have a cube, A square. So we can write, we have A equals to A square. I can ask you if P is constant at any point on this surface. No, because P will change with the depth. So P here is not equal to P here, is not equal to P here. So I talked about this point before. We have to take a small portion of this area where we have a constant value of P at this small area. Okay, and we have small delta F applied on delta A. So in order to solve this problem, we have to take a small area like this. Okay, this area equals to delta A, where if you want to see well, we can take it here like this. Okay, You can take this side of the side. You get the same result. But here we have delta A, okay? And we have delta F applied on this one, because we have a small delta A and small delta F. And we have to calculate the total F by, we can get it by the integration of delta F. You know, here I put the origin O, where we have x-axis and y-axis. Okay? You know, the height of this small portion equals to delta y. We have delta y. The length of this one equals to a. Okay, we have delta y as height and we have a as length. So we can say delta a equals to the height times length equals to a delta y. This is the area of the small portion. We can have a constant p at any point here. P here is equal to P here. At any point, we have the same P. So we can write at this point M, we can say M. We can say here P equals to delta F divided by delta A. Okay, or delta F equals to P delta A. Okay, you know, P at the level of M, at the level of M. We can say PM or P. We can say PM as the point M. As you see here, the point M is at this level, PM. Okay, you know, to calculate PM at this level, you know we have the same P at this level. We can have to take another point here. We can say N, where we have P0. Okay, so we can write here delta F equals to PM. You know, PM equals to P0 plus rho G times the distance between M and N. Okay, let me write in details this point. Okay, here we have the point M and the point N. So PM equals to Pn plus rho G H between M and N. You know the origin is here, okay? And we have Y direction. So in general, the distance between this point and this point is Y, okay? The distance between between M and N equals to A plus H minus Y. Okay, so H Mn equals to A plus H minus Y. If you look well here, you can understand mn equals to a plus h minus y. So we can write here delta f equals to pm, which is equal to pn equals to p0 plus rho g h equals to a plus h minus y, okay, times delta a, which is equal to a delta y. So this is the value of delta f. Let me clear and clean. Here we have delta f. We have to calculate the integral of delta f. You know, I am calculating the force from the internal side. After we have to eliminate p0. Anyway, we have to calculate the integral of delta f and the integral of delta y. You know, delta y will be from 0 to a. You know, delta y will be from this point 0 to the point equals to a is a variable. So here delta f equals to f. We can say here f lateral side from inside, the total f applied from the internal side on the from the internal side of the lateral side equals to integral between 0 and a, between 0 and a, from this point to this point. Here we have p0 a delta y plus rho g a times a, we have a square dy plus rho g a h minus dy minus 0 a rho g a y dy. Okay, so here we have p0a is constant and dy equals to y, and we have a, we can write a directly. Okay, we have a square anyway plus rho g a square dy, we have y equals to a, we have a plus rho g ah, integral of dy equals to y times a minus rho g a, integral of y dy equals to y squared divided by 2. So we have here a squared divided by 2. Okay, so this is the total answer. we can simplify this one. We can say F as the lateral side equals to P0 A square plus rho G A cube plus rho G H A square minus rho G A cube over 2. We can eliminate this one and this one. We have we get here P0 A square plus half rho GA cube plus rho GH A square. This is the value of FL, lateral. Okay, we can write this one. Anyway, the total, as we have an external F0, which is equal to A square times A square times P0, okay? We can say F total at the lateral side equals to only this part, which is equal to half rho GA cube plus rho GH A square. We can have, anyway, we can take a common factor, rho G A square. Here we have half A over 2 plus H. Okay.